can't assume that if an if-then statement is true, that its inverse is going to be true. That's typically not the case. So we're going to talk about the inverse error, just like we did the converse error, and hopefully make sense of that. So the inverse error is basically the fact that you're following the inverse. So the inverse doesn't automatically tell us a true statement. So how did I say that for converse? So I'll try to say it this way. You use the inverse to make a conclusion. Now remember, the inverse is when I add nots to the if-then statement. So up here, this one is kind of helpful in terms of the if-then statement. So the if-then statement, if a number is divisible by 8, then it's divisible by 4. That is actually true. So you can divide it by 8, you can divide it by 4. The inverse of that, if a number is not divisible by 8, then it is not divisible by 4. Typically, if the if-then statement is true, the converse and inverse are both false. So in this case, if a number is not divisible by 8, then it's not divisible by 4 may not be a true statement. 20 is not divisible by 8, so 20 divided by 8 is not a nice number. Therefore, 20 is not divisible by 4. Is that true or false? False. Because again, so this is a false statement. And the reason for that is because the inverse of this original statement is if a number is not divisible by 8, then it is not divisible by 4. That's the inverse of that statement. So this is a true statement. This one's false. So since the top one's true, we can't assume the inverse of that statement would also be true. This next one's kind of long and it involves Pythagorean triples. That might be something you haven't thought about for a while, since geometry, and then you probably didn't think about it much there. So improper induction is basically saying that I see a pattern happening, so I assume that pattern's going to continue. So, maybe just that, like, the last few days we've gone out to eat for dinner because we haven't had much time, so I assume we're just going to keep going out to dinner. That's probably not a safe assumption. I think at some point you'd stop going out to eat because, whatever, you'd run out of money, it's not becoming healthy, you have to break that cycle. So improper induction is assuming a pattern is going to continue. So you just have to be careful about that. So you might think it works for these cases, so it must work for all cases. Let me see if I have a better definition. So the pattern does not continue. And this one, like I said, might be a tough one because you might not remember your Pythagorean triples very well. So, for instance, it said John noticed that 3, 4, 5 is a Pythagorean triple. If you guys remember what a Pythagorean triple was? No.
Is that the triangle?
Triangle. So the Pythagorean theorem is a right triangle. What do I know about 3, 4, and 5?
It's the lengths of all the sides that will add up to correct number.
Yeah, so it's basically the ones that work in a squared plus b squared equals c squared. I didn't expect that everyone would remember that, but 3, 4, 5 is probably the most obvious one. That one shows up a lot on the ACT. So going into the ACT, knowing 3, 4, 5 triangles is helpful. That's, let me show this real quick. That's like if I have a triangle, you'll see stuff like this on an ACT type question, maybe not that easy, but if I see something like that, to take the time to do the Pythagorean theorem, that'd be a waste of time because it's pretty obviously a 3, 4, 5 right triangle, so that's kind of like a basic version of that. So 3, 4, 5 is the Pythagorean triple, and if I multiply 3 times 4 times 5, it equals 60. Then we go on, there's a couple other Pythagorean triples here, 5, 12, 13, 7, 24, 25, and all of them are divisible by 60. So like is John onto something, and are all Pythagorean triples divisible by 60? Do you know any other Pythagorean triples?
No.
No.
Do you have a phone to Google? Google a Pythagorean triple for me other than one of these. See if you can find Pythagorean triple. See what other ones you guys think. You can spell Pythagorean.
No, it's on the board.
Even still,
5, 12, 13,
That one's up there.
9, 12,
9, 12, 15?
15. Yeah.
I bet that one, because that's multiples of that one. I bet that one is multiples of 30, or
6,
divisible.
8, 10.
That's same. That's like multiples. Really? You guys didn't find any unique ones? Yeah. Everyone?
Are any of these?
Yeah.
But they kind of, I did the factor off of one.
Oh, yeah. Oh, yeah, those are all off of 3, 4, 5.
8, 15, 17.
8, 15, 17. That one sounds pretty good. Let's try that one. Okay, 8, 15, 17. So requires I grab my trusty calculator. Oh, if I could multiply correctly. Why does it keep doing 11 instead of?
Because it's not reading your.
I'm just up here to laugh at. Okay, so 8, 15, 17. Is that divisible by 60? Is it?
Probably.
Dang it, it is. Maybe John's right. I don't think it's supposed to be. What other Pythagorean? Maybe
9, 25, 16.
no, that's another. Cause those, so the ones you're listing that I'm telling you no are all multiples of these. So you said 9, 12, 15. Did you say? Anyone got one?
13, 84, 85.
Ooh, that one sounds pretty good. 13, 84, 85. I'm hopeful. Anyone try it? 13. Otherwise, this problem's a bust.
I think it's a boss.
A bus for me goes out your
Why don't you just go like the one that doesn't work? Hit the right next to where you now do.
Oh, thank you. I didn't know that that was that thing.
Oh no, it's gonna be.
I
It's
bet
gonna be
it
divisible.
is.
So
I think John's right.
John Boyd is.
I think John.
15, 112, and 113.
What is it?
15, 112, and 113.
15, 112.
And 113.
I think it's still gonna
I feel like it's
work. Yeah, it ends
It's
with
gonna be the divisible
It's
of
gonna
60.
work.
John.
I swore I found that this was not supposed to be a real thing. Where did I see that?
Holy moly, John.
Wait, why don't you just search are all?
I did.
Look up
Divisible, and it said, I'm pretty sure it said
I have to see where I found this. I don't remember. This one might have been like late night note writing. I know, seriously.
Yeah, it is. Why is every
Oh,
topic
you guys. It's actually valid. So, John concluded. Oh. Oh wait. No, it says it's an example of improper reduction. I don't know. So these, it must. I don't know if it's a true. I don't know. There's got to be something out there somewhere. That's extra bonus points if you find one that doesn't work. I don't know.
So far, we can't prove it.
I know.
nice.
I have to look into this a little bit more. But
I see skimmed it.
All right. No, well, it's fine. Well, we didn't find one, but okay.
That was not me.
What?
Okay.
What's that idea?
I'm sorry, Cash. It was Bella. It's confirmed. I'm never doing it again.
Imagine that for the rest of the class. Would it be very
Imagine what?
just like
Okay. All right. So this statement, this is my recruiting for the math team. If the person's on the math team, then they like math.
Oh, I should.
I mean, I hope so.
I mean, you guys, or you're just like going places in the van with
Yeah,
me.
we like
Yeah.
that.
Okay.
Yeah.
So some of the math team members maybe just want to go places in the van and sit down and okay, got it. Like, I remember once we were driving and Jolie's like, you could like be our aunt or something like that. Like we'll like be adopted. And it was like, what is going on? Like how do I
Remember that time we got stuck?
I'll never
on the
forget that
ice?
time. I think I still have nightmares. I almost killed Paige. And were you in the car? No.
God, no. Alexa proud.
You would not have forgotten that
Talon
time.
was.
Talon.
I was sitting
So
next
we were stuck in Plymouth. Like the road became absolute ice, and all these cars were spun out, and like people were out of their cars, just like walking around on the ice, and like we like stopped the car, but like
a semi came behind us.
yeah, it was like
Couldn't
sliding
stop.
into us, and I was calling Mr. Engelbrechtson to be like, what am I supposed to do? Like we're stuck. Like I should not be driving a car full of children when
Yeah.
like you know like it was so scary. I almost killed them. So we started going, but no one else was going. They're all just chilling like on the freeway. Like and Mr. Engelbrechtson, this was his thing, was like I was
It's not icy by my house.
he lives in Plymouth and he's like, I just went outside, it's not icy. And I'm like, it's icy. Like I mean like the road
about your house.
right, and like, okay, we'll come there. Like we'll be there in 5. So like,
Make it time.
it was terrible. Like I've never been more scared driving in my whole life. I mean it helped that like all of you guys were in the car and like I mean, like Talon's on what? They were well that made it extra terrifying because they were scared.
Talon and I were sitting in the way back, and we kept looking back, and all of a sudden the semi was so close to us we couldn't see his lights anymore. And we
Yeah,
were like,
she's like, and he's like
Please
sliding,
go.
trying to stop, and I was
Yeah.
like trying to go, but not too fast because the wheels would spin. So I was like going really slow and like, oh my gosh.
I was gave her challenge, but it's fun.
But there's literally
Oh,
people
yeah.
standing outside their car just
yeah, and
talking.
there were like cars like facing
You're like, oh
the
my gosh,
wrong
this
way.
weather's crazy.
Yeah, like this, and I'm like, you're gonna get hit by a semi.
And it was like 9 o'clock at night. It was
Yeah.
like,
we were coming home from the boarding school.
yeah,
Yeah.
yeah.
Because we left the school and we all like slid down the hill, like because it was so icy. Why we?
Holy moly.
Yeah, it was a night to remember. When I got here, Mrs. Wilterding offered to drive me home because she like knew how terrified I was. I'm like, I think I'm good. I'm just gonna go slow. Oh, I was just yeah, I was nice. We just leave it at Mr. Engelbrechtson's house. All right. Okay. So we're gonna use the Venn diagram, which sounds bad, but it's not. Venn diagram. You guys have seen this before. So it's a big circle. So if the person's on the math team, then they like math. We might need to change the circle because apparently not everyone on the math team really likes math. So then in that case, we kind of have a little circle hanging out here. So there's some people. We're going to assume though, we're going to move them in there. We're going to assume they like math. Now does everyone who likes math, are they all on the math team?
No.
No. There's people who like math who like don't want to hang out with me and drive and like risk their lives. So people who are like math, are they the bigger circle or the smaller circle? Big. So like liking math is more common because there's not that many people on the math team. We only have a van. So like math is the big people. So they like math or are good at math, maybe we could say. Then the smaller circle is out of those people that like math, those are the people I would ask to be on the math team. Like if there's a kid that's obviously miserable in my class, I would be like, hey, join the math team, let's hang out. So like, no, like we get a little more specific so that you could be on the math team.
Wait, what does the math team do again?
We travel to other schools and we like they do like paper pencil tests that are like problem-solving questions.
And most of the time, none of those get on the same.
Talon and Blake
Yeah.
win, and
Yeah.
we just all support them. Any cookies
Yeah.
and milk.
I remember one time I remember one time I didn't get any points. That actually happened more than once.
I don't judge you. I just appreciate you coming along. All right. So it says, write the converse of this statement and determine if it's true. Write the inverse and determine if it's true. So kind of similar idea that we were talking about before. We're going to say that this first statement is true. So a person on the math team, then they like math. So just lie to me and tell me you like math if you're on the math team. Like, you know, like don't hurt my feelings. Okay. So the converse, this is kind of a review of our converse and inverse, just to remind you guys kind of going into the test. The converse is the one where we flip the two parts. If they like math, whoops, too many L's in like. Then they are on the math team. Whoops. If that were true, we'd have a whole bus full of kids, wouldn't we? Okay, so is there a possibility that there is someone in this building who likes math who is not on the math team?
Yes.
What?
Yes.
Yeah, that is totally possible. Maybe they have a conflict. Maybe they don't want to ride in the car with me. You know, like there's all sorts of they want to risk their lives on the road. So if they like math, it doesn't mean you have to be on the math team. So this could be a false statement. We can find someone in the building who's not on the math team, but they like math. So that's false. So again, the idea is remembering that these two are usually opposites of each other. If they're both true, then we can use that if and only if idea. That boarding school, though, all the kids are on all the teams. Like, they have like.
had like 16.
Yeah, but I think you have nothing else to do. So you're like, I'm going to join the math team because I'm here, and they get cookies. So they feed us
Wait,
like
wait, did they actually give you?
yeah, after like when we're waiting for the results, we get cookies and milk. Like,
Yo.
and we go to Dairy. We usually stop for food somewhere. So we make a night of it. It's a wild night with the math team. All right. The inverse of this statement. So again, we're going back to the original statement. The inverse is the one where you add the nots to it. So you're throwing nots. So if a person is not on the math team, so not on the math team. So Stone's not on the math team, and then I yell at him, Stone, why do you hate math? Like, no, I don't. Right, he doesn't. So that's not a true statement. Then they do not like math. I don't have to be offended. So these two statements are generally the same outcome. So this is also false. I can, just because they're not on my team doesn't mean they hate it. Or it doesn't mean they don't like it. All right? Questions there? All right, I filled up a little bit more of our time this time. So we have some homework listed there. Remember that first section? Oh, so kind of that first little group of problems that we did. Sorry, Ash. Yesterday. But yeah, so homework is listed there for you guys. Should be online, yeah. Yes.
No.
I thought you were going to ask if you can join the math team.
Can I do that too?
Get cookies.